Dear students, myself is Aravind. I am working as an assistant professor in Department of Mechanical Engineering, Konganad Engineering College. Today we are going to see about a topic in TTS. So the topic is gear. So these are the contents we are going to see today. Start with the definition of gear. So a power transmission is the movement of energy from its place of generation to a location where it is applied to a performing of useful work. So yeah, for this purpose, a gear will be used. So gear is a component within a transmission device that transmits rotational force to another gear or a device. So it's mainly a power transmitting element. This is the types of gears. First of all, start with parallel, and next thing is intersecting. The third will be a non-intersecting and non-parallel. Each thing having a designated different types according to their perspective. First, spur gear. So the teeth is from the image itself we can see it has a design of teeth around a circle. So the teeth is parallel to the axis of rotation. So the main design of this kind of gear which is helpful to transmit a power from driving shaft to a driven shaft. So it will be used in many applications. Let's start with an electrical screwdriver, oscillating sprinkler like washing machine. It can be applied in many ways. So in the GAF you can see the one A will rotate in anti-clockwise direction and the B will be rotating in clockwise direction. The type 2 will be a helical gear. The teeth on helical gears are cut at an angle to the face of the gear. The main difference between the spur gear and the helical gear is the angle the teeth makes with the circle. This gradual engagement makes helical gears operate much more smoothly and quietly than spur gears because the connection between the mating gears will be very much efficient compared to the spur gears. One interesting thing about helical gears is that if the angles of the gear teeth are correct, they can be mounted on perpendicular shaft adjusting to the rotation angle by 90 degrees, which cannot be possible in spur gears. So this is how a helical gear looks like. It can be used in a normal way or will be in 90-degree angle. And next will be a herringbone gears. From the image itself you can see can be similarly look like a helical gear, but the angle will be slightly increased compared to helical, right? So to avoid axial thrust, two helical gears of opposite hand can be mounted side by side to cancel resulting thrust forces. I already told this is similar to a helical gear. So herringbone gears are mostly used on heavy machinery. The final is rack and pinion. It will be have rotational movement to translationary movement reactions. So the rack and pinion gears are used to convert from rotation from pinion into a linear motion, which I said before. So a perfect example for this is a steering gear. In an automobile, we have a steering. So in that we can rotate in clockwise and anti-clockwise, but the wheel will rotate in a reciprocating movement. So this is a primary example of rack and pinion mechanism. And is the bevel gears when the direction of the shaft of rotation needs to be changed, like 90-degree angle. So it will be an X direction and another gear will be in Y direction. So they are usually mounted on shaft that are 90-degree apart but can be designed to work at other angles as well. The teeth on bevel gears can be straight, spiral or hyper. The main applications will be on locomotive marine applications like train inspection, etc. This image, X-ray image shows that exact view of a straight and spiral bevel gears. And the next thing is about worm and worm gear. It has a speed reduction ratio of 1 is to 300. Like when you have a higher speed, but you have to work the machinery at the slow speed, you can apply the worm and worm gear in here. So it will be used for large gear reduction. Common for worm gears, already said that. has speed ratio of 300 is to 1. Many worm gears having an interesting property that no other gears it has. So worm gears are widely used in material handling and transportation machinery. So it's a pictorial view of worm and worm gear. So this is a nomenclature of a gear. From the image itself, you can see the main parts of a gear, starting with the distance of addendum circle, dedendum circle, and you have a vertical angle of a first width, and you have a circular thickness, and you have a flank which will be connecting the two meeting points, and you have a clear distance between addendum and in between the dedendum. So these are the basic points which we have to understand from a gear. So next thing is gear trains. So a gear train is nothing but two or more gears working together by meshing their teeth and turning each other into a system to generate power and speed. It reduces speed and increases torque. Electric motors are used within the gear systems that will be used to speed and increase the torque. And the gear trains have three types, starting with simple gear train, compound gear train, and planetary gear train. So the image shows of a simple gear train. From that it can see the all gears which will be connected parallel to each other and each will be rotating in their own motion. The next thing is about compound gear. So can go for large velocities, compound arrangement is preferred. Two or more gears may rotate about a single axis. So previously in single axis we have only one gear. In case of a compound train, we have two or more gears which will be acting on a single line. Finally, planetary gear train. In a single system, we can have many gear trains and have idler gears also. So the size of the red gear is not important because it will be an idler gear. In this gear system, the yellow gear, which will be named as sun, engages with all the three red gears, as I said before. Yeah. So all the three are attached to the plate and they engage the inside of the blue gear instead of the outside. This is called a planetary gear train. And what are all the kind of materials which can be used in gears? We have metallic materials and non-metallic materials. In metallic materials, we have steel, cast iron, bronze, and in case of non-metallic materials, we have wood, compressor paper, and nylon. So, thank you.